Well, hello there. Word break 2, LeetCode. I know what happened. You're on this question. You're like, I can kind of see how it's, you can get the first word and then, maybe get like the subset problems, sounds like recursion. And then you go to solution, 2 stars, yep, no thank you. You go to discuss, absolutely zero comments, of course, in any of the solutions, so you can't understand anything. Well, I'm here to save you. All right. Word break 2. Let's do it. All right. Let me just kind of break down the problem real quick. Just kind of talk about it from a top level point of view. If you don't really understand the problem, just kind of try to keep following along. Let's take example 2. We have pineapple, right? So we need to find the words in the dictionary in this problem and then give all of the possible solutions separated by a space. So in this problem, let's see, we can say, all right, we got pine, right? So pine, and then all other substrings, right? So we're going to have apple, pen, apple. The next word is going to be apple. So pine, apple, all other substrings. There you go. Right. We also have apple pen. So we're going to say pine, apple, pen, all other substrings. So pine, apple, and then let's see, we got pen, all other substrings. Pine, apple, pen, apple, all other substrings. But all we have is just nothing after apple. So that's one of our solutions. Pine, apple, pen. Let's see. Pine, apple, pen. Let's see. Apple. All other substrings. But after apple, it's just going to be an empty string. So we have nothing else. So these are our two selections. So these are our two answers for a string that starts with pine. But we also have pineapple, which exists in the word dictionary. So we're going to need to have pineapple, all other substrings, which in this case is, so pineapple, it's going to be penapple. So we're going to have pineapple. Pen is the only other thing you can get from penapple. All the other substrings. Pineapple, pen, apple, all other substrings, but we've reached the end of the string, we have nothing, and there we go. That's our third solution. So, yep, looks good to me. So, what's an important thing to note about this? There's two things. Okay, no, there's not, but the main thing to know is that we are allowed to reuse a dictionary word. That is a huge hint into what is one way to optimize this solution that we're going to be doing, okay? It's memoization. We're going to say, well, we've seen apple, for example, before. So we can just say if apple is in the string, just return it back to us. That'll save a lot of processing time, things like that. All right, so basically we're taking a string at the beginning and then separating that, adding it to our answer set, and just appending all other solutions for the subset. Sounds like recursion. It is recursion. So I hope that's enough for me to begin coding. So I'm going to go ahead and get into that right now. I'm going to go ahead and say public list string, because we're going to be needing to return a list at the end of the day. And I'll just call this word break helper. We're going to have the same arguments as the original function. All right, so As with any recursive function, we are going to need to talk about a base case. So let's say we pass an empty string into one of our arguments, or into the argument, right? Even though the question says given a non-empty string, but let's just say you do, for the sake of the base case, right? So we know that we're going to have to return a list of strings. So we'll say results is equal to new array list. Okay. If the length of the string is 0, so we have an empty string, then we're just going to want to say, okay, the result list of an empty string is an empty string. There's no results. That's going to be our possible, result. So we're going to add the empty string to it and then just return results. Okay, good. Otherwise, we're going to want to break the string apart and append the substrings to the first words. Like in this case, pine was one of the first words. Then we have pineapple was the other first word before we ran out of possible beginning words. And then once all is said and done, we're going to want to return the results. Okay, so let me go ahead and, before I forget, call that up here in the regular function. So I'm going to say return word break helper, pass the string, and pass the dictionary. Okay, good. So, all right. Looking good so far. Now, we need to work on the actual meat of the recursive function. And recursive functions suck. I hate them, but I really, really hope I can help put this idea into your head on how we're passing the subproblems to the recursive function. So we're saying, I know that this string starts with pine. What I don't know are all of the other substrings. But I know there could be more than one. So, right, so we have pine, there's this substring, and then pine over here, there's this other substring. So all I know is that I have my first word with a space, and then a list of other substrings, as you can see up here, that we're returning from the recursive function. So we're going to say, all right, just give me all of the possible subsets for this word. So let me go ahead and identify the first words in the string that we have. Okay? So I'm going to say, for each word in the dictionary, right? If s.starts with the word, so we've identified, if penapple starts with one of these words, in this case, we're going to have pineapple. We're also going to have pine. So if the string starts with this word, give me all of the subsets, okay? What does that look like? We're going to recursively call our function. We're going to say, give me the subsets after our word, okay? So we're going to say subsets. I'll call it substrings, just for the sake of language, right? Is equal to our recursive function. And we're going to want the substring after the word that we've identified. So we're going to say s.substring, and then give me everything after the index of the word. So word.length. Now, if in case you don't know, let me just say it real quick. So I'll just say is equal to, all right. So substring basically says, from an index, give me everything afterwards. So pine is of size 4. So we're going to go to 0, 1, 2, 3, 4. It's inclusive on the index that you choose. So it's going to include A. Give me everything afterwards. So that's what's going on right here. All right. So I'm going to pass along the substring so we can work down that, and then just pass the dictionary. So we're handing it off. We're saying, look, I have my word. Give me all the possible solutions after this word, right? Now, we're going to need to start filling out our results, okay? So for each, that's PHP, my bad. So for the substring in substrings, we are going to say, results dot add the word plus a space plus the substring. You know, we don't know what that substring is, but it's going to be returned to us. So in this case, you know, one of them will be apple, pen, apple. The other one will be apple, pen, apple. And then for pineapple, it'll be, you know, pineapple and then pen apple. So, yeah. But there's one important thing to make note of, and that's that this space right here, what happens whenever we hit the end, you know? We're going to have an empty string here. We don't need a space for an empty string. So what we're going to say is optional space is equal to the substring. Is it empty? If it is, then we don't need a space. Otherwise, give us a space. So we're going to say the word plus an optional space plus a substring. So from a top level point of view, we're saying, you know, for pine, give me all other substrings, which in this case is going to be, you know, apple, pen, apple. But whenever we're calling the recursive function, we're also passing along this substring. So we're also going to have, you know, a sub problem of apple. Give me all of the substrings. All right. Let's see. The thing after apple, the only word that we can find is pen. All right. Give me all of the substrings. All right. Well, the last one is apple. Okay. Give me all of the substrings. Now we have nothing. Hit the base case. Add that to the result, and it just bubbles up. So it's going to be on this one. It's going to be apple plus. It's going to be something like apple plus nothing, right? And then on the next one, it's going to go up to pen plus, well, this is not empty anymore, so let's give it a space, plus apple, and then it's going to bubble up again, so it's going to say apple plus space, pen, and then, you know, it goes all the way. So pine plus. That's how it's building the string going up, basically. Return that as a result, and we should be good. So let me go ahead and call this, or run the code right now and hope that it works. Let's see. Oops. S dot, what is it, starts with? Starts with the word. Come on now. There we go. All right, perfect. So it's working. If I submit it, I'll get a time limit exceeded, and there's a very good reason for that. Let me just go ahead and do it just so you can see it. Ignore all of these where I was practicing. Just forget about it. They give you a really crazy test case of just a huge, you know, troll string, in which case you're going to be doing the same calculations over and over and over and over again. So how do you get past that? Well, you can store the results that you're getting. You can store them. And if your string exists in the set of solutions that you found, just return the array list, right? So adding memoization to this is really, really simple. We're going to say, like I mentioned, we're going to need a new argument in our function. It's going to be a map, okay? So if you're not familiar with maps, go ahead and look it up. They're very important in data structures and algorithms. So the key is going to be the string that we're passing to our function, and then the value is going to be the list of strings that we have being returned. So we're going to say list string. Let's see, memo. All right. So what we're going to say is if memo dot contains key, of s, just return the value. I'm sorry to flex my LeetCode premium, I'm getting all this helper function stuff, but anyway. So if the key exists in our memoization map, just return the array list. But if not, do everything we need to do, and then at the very end, just go ahead and add our solution for this string. So we're going to say results. And up here, we're going to need to add our new map. So we're going to say new hash map string, and then pass along a list of strings. And then, of course, we call the function recursively over here, so I'm going to need to pass our new argument. And let's hope that this runs properly. Okay, it does. Let me go ahead and submit it. And there you go. You've added memoization to your answer. All it's doing is saying, okay, I've encountered a solution for this string. Let me just pass the solution that I found. Next time that that solution is found, it'll just return it quickly without having to do all of this recursive calling. So I hope that was helpful. The video is a little bit long. The reason that I made this video is because I couldn't really find a whole lot of great information online. Not dissing all the other channels out there, but I just wanted to give my own spin on the solution. Donate to my Patreon. Just kidding, I don't have a Patreon, but good luck on your interviews. Just study. It's difficult, but you can do it. I wish you the best. Take care.